Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. So in this video, we're going to really talk about derivatives and the shape of a graph. And we can actually learn a lot about a function based off of how its derivatives work. And so it's just kind of putting it all together. So we need to understand how does f compare to its derivative and even to its second derivative. So there's characteristics of these two that are going to be shown in this one. So keep that in mind, all right? So if your derivative, your first derivative, is greater than 0, f of x is increasing. Because it's your slope, right? If your slope is greater than 0, you're going uphill. And if it's less than 0, if your slope is negative, then your graph is decreasing. Okay, now, if your derivative equals 0, you will have a local max, local min, or you could have an inflection point. Okay, so an inflection point is where you change concavity, which generally is done in the second derivative. If your second derivative is greater than 0, your graph will be concave up. If your second derivative is less than 0, your graph will be concave down. Think of that like smiley face, frowny face. Up, down. Okay? Now, if we put those together, right? You don't really have to put them together, but if the first derivative equals 0 and your second derivative at C is greater than 0, means concave up, right? So we're concave up, but our derivative is 0. Oh, we have a local min. If your derivative is 0 and your second derivative is less than 0, meaning concave down, we have a local max. It's not really how I like to check for them, but we can do it that way. So let's just go ahead and let's see how much we can get graphed of a graph without ever touching a calculator that does it for us, right? F of x equals x to the fourth minus 4x cubed. Well, I happen to know x to the fourth graphs because it's an even degree. I learned in Algebra 2 and in college algebra that my end behavior is going up, and we probably have a W-ish type shape. Or fewer curves, we're not sure, but we probably have that. Okay, so we're going to take my first derivative, 4x cubed minus 12x squared. We'll factor that. So 4x, x squared minus 3. Or could I pull it? No, I could have pulled it at 4x squared, which would have given me an x minus 3. There we go. So my critical numbers are 0 and 3. Okay? If I were to use this equation And I were to pick a number smaller than 0, like -10. It'd make -1,000 minus 1,200. That's definitely negative. If I were to pick something between 0 and 3, like 1, 4 minus 12, that's negative. And then something bigger than 3, I'm going to test 10. That would be 4,000 minus 1,200. That would definitely be positive. So it looks like we're going downhill, downhill, uphill. All because of our, which makes sense with our equation, kind of that W-ish look, okay? So now we're going to check that second derivative. So give me 12x squared minus 24x. So I'll factor out a 12x, leaving me an x minus 2. So it looks like a critical number of 0 and 2. And if I pick again, I just like -10 because it's easy to work with. That'd be 1,200 plus 240. So it'd be positive. So that would be concave up. If I plug in 1, 12 minus 24 is negative. That'd be concave down. And something like 10, that would be 1,200 minus 240. So that's definitely positive, so concave up. Are we seeing the concave up right here? Then concave down. Then concave up. Okay. So points that we came up with. Zero, 2, and 3. Okay, and if I come back up to the original, I'm going to go ahead and factor that. X cubed, x minus 4. We have x-intercepts of 0 and 4. So our F equation was x to the 4th minus 4x cubed, 0 and 0. If I substitute 2 into the original equation, my position is -16 and -27. So here's what we know. We know we're going to cross at 0 and 4. We said that the concavity was going to switch at 0. We also said it was going to be downhill, downhill, right? 1 is supposed to be my bottom point, my low point, right? No, where was my low point? 3. Not until 3. I tested 1, that's what it was. My low point's at 3, and I come back up. But if you look here, we've got the concave up, concave down, and then 2, that 2 -16 is where we inflected from concave down to concave up. So we have all of our points of concavity. And let's go ahead, x to the 4th minus 4x to the 3rd. Now I'm going to make sure my window is from -10 to 10, but I know my minimum is -27, so I'm going to go down to -30. We definitely see that inflection at 0, 0, because we were concave down, then concave up, concave down, and then some point in here we had to switch again. That happens to be at 2, where we can flip back around. Okay, so we had 2 inflection points, and we only had 1 minimum. And that can happen. But every little piece about the equation tells you something about the graph. This is how we graph prior to having graphing calculators. Okay? So f of x is going to be your location. It's going to be your ordered pairs. Okay? The derivative is going to be your slope, or instantaneous velocity, and the second derivative will be your concavity or acceleration. All right, so let's try one more. Let's see if we can get all the critical numbers without even doing too much work. So we've got this equation right here, x cubed plus 5. When I derive it, I get 3x squared. And when I derive that, I get 6x. So this only equals 0 at 0. And if I substitute a negative number in, I get a positive, and I substitute, okay? So the slope is always increasing. Okay, if I set this equal to 0, again, it's a critical number at 0. But when I put something in smaller than 0, I get negative and something bigger. So this is going to always have a positive slope. So it's always going uphill, but it's going to start with downward curvature, and then it's going to switch to upwards curvature while always maintaining a positive slope. So let's check it out. X cubed plus 5. There we go. I forgot to change my window from a while ago, but we can see that. So this person is always accelerating, right? So just understand that the derivative tells you whether you're going uphill or downhill in a graph, and the second derivative tells you about the concavity. Are you concave down or concave up? So just double check, and most of us have a graphing calculator so we can verify what we're seeing in our equations versus what we're seeing in our picture.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.